All right, so this is going to be a sad day for you because this is the last unit before we start reviewing for the final. And we are going to be doing all of Unit A is about applications of integrals. So we're going to be doing applications of integrals a lot and some other things. This first section is about learning the average value theorem. This is going to be on the AP test somewhere, sometimes multiple times. And this is 8.1, so you need to start your worksheet after you get done with the test, the Unit 7 test. Now this is the mean value theorem for integrals. This is not part of the AB curriculum, but if you look up here and see what this is where the average value theorem comes from. And it comes from taking this thing and dividing both sides by that. So if we take that and divide both sides by it, this right here is the average value theorem. So the average value theorem is going to take 1 over b minus a, and b minus a are your intervals, and it's the integral from a to b of whatever your function is dx. So here's my function right there. There's your function, and we want the average value on these intervals. So the average value is going to equal 1 over 5 minus 2 integral from 2 to 5. And again, these 5 and 2's all come from this thing. This is a, this is b, and then the integral of this. So I can stick that 2 out here in front, or I can leave it right here. It does not matter. And I have e to the negative x squared dx. And then this says calculator, so I'm going to show you how to plug that into your calculator. Let me get it where I can see it. Okay, and then I'm going to zoom in here on my calculator. So what you're going to hit on your calculator is we are going to hit alpha y equals 1 for fraction bar. I'm going to put 1 over 5 minus 2. Now if you just put 1 over 3, that's fine. And then we hit math 9, and we're going from 2 to 5. And we're going to come over here and put in 2x second natural log e to the negative. Make sure you use the negative by the decimal point. If you use a minus sign, it'll give you an error. X squared dx, and we hit enter, and there's, oops, what did I type in wrong? Oh, the 5 wasn't in there. Okay, so there is our solution to that. And how many places do we round to in here? I hope everybody's telling me to 3. So we're going to round this to 0.006. Now, if you put more than 3, you want to stick that 1 on out there, or 0.5213, you can, but you have to have at least 0.006. Find C such that the average value of f of x is equal to f of c. Well, this is more dealing with the integral theorem, which is not on the test, so I'm kind of going to skip that. I guess I could show you what you're going to do is you would take this function here, and what you would do is you would take this function, even though this is not part of your curriculum, and you would say that equals your 0.0061, and I probably wouldn't round it. I'd write the rest of that out, and then you would want to solve that on a calculator. So if you put y sub 1 equals this and y sub 2 equals that, and find their intersection, those would be the answers. And if you want to know the answers, this one's 0.003 or 2.598. Both work, but I'm not going to do any more of this integral stuff because it will not be on your AP test. Find the average value of this function from 1 to 4. Now I'm not going to use a calculator because it doesn't say 1, because you got to do some without it. So your average value is going to be 1 over 4 minus 1 integral 1 to 4 of the function 3x squared minus 2x dx. So we're just going to do our power rule. I'm going to get 1/3 out front, and then I'm going to have 3x to the third over 3. So those 3's will reduce, minus 2x squared over 2. So those 2's will reduce, and then we're going to do this from 1 to 4. So this is going to equal 1/3, and then we got to put in our upper value of 4. So this is going to be 4 to the third minus 4 squared, that's our upper value, upper interval, minus, and then we put in our lower interval, 1 cubed, and you got to have parentheses here because you got to distribute the minus sign, minus 1 squared. I guess it really doesn't matter on this one. So this is going to be 1/3, and 4 times 4 times 4 is 64, minus 16, minus, and then we got 1 cubed is 1, minus 1 squared is minus 1. So that is all 0. This thing right here is 0, so I'm going to forget about this part. And 64 minus 16, I believe, is 48. So this whole thing would equal 16. So the average value of this graph over here is, and he even put it up here, that's 16 value. This is the average value of this function. Okay, now this is, again, this says mean value theorem of integrals, not on your test, and if we are not on the AP standard. So if we have a problem on the test like that, we're not going to do that problem, okay? All right, coming over here. All right, now this is the chart. You will have something like this possibly on the AP test, because this stuff is, you gotta know functions, you gotta know charts, and you gotta know graphs. Those are the biggies. So this says estimate the derivative of m, and I guess we better read this. The cows on a small dairy farm in northern Indiana are milked in the morning during a 2-hour period. The milk from the cows are pumped in a storage tank, and the volume of the milk in the tank at the time t modeled by a strictly increasing, this is probably going to be important, it could say monotonic there too, twice differentiable function. So we need to, because we know it's twice differentiable, we need to say somewhere that m is continuous on the interval 0 to 120, because it's twice differentiable. So we need to say that that is true, that that thing is continuous. I don't care if you use brackets or parentheses. Where m of t is measured in gallons and t is measured in minutes at time t equals 0. So if you notice, this is gallons, this is minutes, and m, this is regular m up here. I'm going to write down my, I guess I don't need to because it's right there, but 0,300 is the original amount of milk in the storage container. And we've got these different deals here about different times that the milk's being pumped from them. And again, I want to underline this because t is in minutes. All right, so m prime means I want the slope at 70. So you want to look at your minutes up here, and you want the two closest to 70, which 70 comes between these two. So we are going to say m prime of 70 is going to be, and I hope we realize that we need this is derivative, so we need gallons over milk. So I'm just going to take 3,360 minus 1640, it's the y's over the x's, over 90 minus 50 gallons per minute. Now, you could leave that as your answer and get full credit for that. Or if you want to simplify it down, it does simplify down to 43 gallons per minute. So that would be your, and we'd probably want to say at t equals 70 minutes, because we need to tell them a time. So that would be the amount of milk going into the container. Okay, I guess we probably should say this. This is milk, amount of milk, probably should say that, or gallons of milk, the amount of milk going into the container, into the storage tank, I'm just going to put tank, into the tank, is about, because we are approximating, because it's an estimation, because we don't really have 70, is about that. Use the data to evaluate the integral from 0 to 20 of m prime of t dt. Okay, so again, this is m up here, and this is asking us to evaluate m prime, the derivative, and it says use correct units to interpret the meaning. And then we're supposed to talk about that in terms of the problem. So let me do this real quick. So 0 to 120 of m prime of t dt is going to equal capital M of 120. This is the fundamental theorem of calculus, minus capital M of 0. So up here's capital M. So M at 120 is 4,250. And then at time 0 is 300. So this would, again, you could leave that as your answer, but it's 3,950. And again, we are doing the inverse of this. So this is gallons of milk, okay? Gallons, that is in gallons. So to interpret this thing in terms of the problem, we would want to say 3,950 gallons, if I could spell, gallons of milk were pumped in or added to the tank from t equals 0 to t equals 120 minutes. And that would be the way we answer that question. Okay, this next question says, use a right-Riemann sum with 4 subintervals to indicate the data from the table approximate, and so this wants us to approximate 1/20th of this. So this is asking us to approximate, I hope you realize, the average, because 120 minus 0 is this. This is the average value theorem. Okay, and explain the meaning of this expression in the context of the problem. Does this, all right, and we're going to want to know, is this an over or under estimate? And then it wants us to find the exact value of that problem as we go through this deal here. All right, so first of all, I would kind of want to, I'm going to make a chart of this, and I'm going to kind of make it realistic here. So I'm going to come out here and put that's 120. I'm going to put that this right here is 0, and 20's in here somewhere. I'm going to have to move it over because there's that thing's in the way of my deal. And then 50's here somewhere, and 60's here somewhere. And so I've got 0, 30. I got 20. At time 20, we're at 780. Oops, that's 300, not 30. My bad. 780, and then at 50, we're at 16 something, so I didn't make my graph big enough, so I'm going to make this thing 1640. And then at 90, we're at 3360. And then we're at 4250 out there at the end. And I probably shouldn't have made it this big, but out here, we're up here, right here, we're here. Let me get this out of the way. At 50, we're here. At 20, we're here. And we are doing a right Riemann sum, so I don't even need this point. So if we think about this graph, we know it's continuous. We really don't know what it's doing between the points, but it's something along these lines. And I'm doing a right Riemann sum, so I'm going from the right side, and I'm going to make rectangles going backwards. So there's 1, there's 2, there's 3, and then this one would be the 4th one right here. So this base down here is 20, because 0 to 20 is 20, 20 to 50 is 30, 50 to 60 is 10, 60 to 120 is 60, and then this height on the far right is that 4,000, because we're doing a right one, 4,250 from up here. The height of this rectangle is 3,360. This one is 1640, and this last one is 780. 780. So let's go down and do our area of rectangles. So we are approximating this one. So we're going to get 120 integral of 0 to 120 m of t. dt is approximately, and we're going to start over here and do this base, which is 60 times 4250 plus this next one is 10 times, I think that's 3360, I hope. Plus the next one is 30 times that height is 1640. And then the last one is 20 times 780. Okay, and we got this whole thing times 1 over 120. If we keep that in the front. Okay, that's good enough for the answer, or you could calculate it out. 2722.5 gallons. Okay, so what this is saying, we're supposed to tell what this means in terms of the problem, and it means the average amount of milk in its tank in the tank. Put tanks, it should just be tank, is about 2,722.5 gallons from T equals 0 to T equals 120 minutes. So that's what that's all about. And now we're supposed to tell us this estimate. So look at if you draw your chart kind of nice, it helps you see if this is an estimate or if it's an over or under estimate. So if you look, we're doing right. So I hope you can see that this part and this part and this part and this part are all too big. So our approximation is an overestimate because we're using a Wright-Riemann sum Wright-Riemann approximation on if you remember up there at the top, it said on a strictly increasing interval. Because if this graph is continually going up and you're starting from the rights are all going to be greater than the lefts. That's why that strictly increasing thing came back into play there. So I think that's the last part. I hope you guys have a good time on this first homework, and I will see you next time in class.